All right, so we're on to 3.5, which is equations with variable on both sides. So before, we've only had it on one side, so we haven't really had to do anything with combining those. We've we've combined like terms before, so this is kind of similar. So far we've been talking about undoing addition, subtraction, multiplication, and division of real numbers, and now we're looking at moving a variable. Okay, so we're going to move it from one side to the other. Now, people get confused. There's a difference between, undoing it and subtracting it so that you can like move it to the other side, and just combining like terms. Okay, if they're on the same side, you just combine them. You don't do the opposite unless you're actually moving it to the other side of the equal sign. Now, we will need this to do this if there's a variable on both sides, and the goal will still be to solve for the variable. Solve for the variable. But now we need to isolate the variable on one side. Preferably the left. I'm going to put left because I like to do it on the left side. But again, doesn't matter. And any other numbers without variables on the other side. Okay? So that is our goal. So I'm going to take this first one and I'm going to subtract 4x because this is a positive 4x. So in order to get rid of it, I need to subtract 4x. They cancel each other out. Do that on both sides. So 6x minus 4x is 2x. So 2x equals 18. And then once we get here, we already know how to do this. We know that we need to divide both sides by 2. So we get x equals 9. Next one, okay, so we have 3y equals 15 minus 2y. Again, bringing the y's together. So adding 2y on both sides. So that gives us 5y equals 15. And then we can divide by 5 to get y equals 3. Alrighty, we have fractions, our favorite. So I am gonna do everything on the let's do it on the right side. We can do it on the right side so we don't have to move the 3 over over to the left and then back. Again, it doesn't matter which side you do it. So I'm gonna subtract 4/5 x on both sides. Okay, and over to the side, over to the side, I'm going to think of this as x minus 4/5 x, okay? Well, I know I can think of this as a 1, right? 1x. Or I can even think of this, or I can even think of this as a 5/5 x, because 5/5 is 1. So that will make this way easier, because 5/5 minus 4/5 is 1/5. So now I'm going to have 3 on the left and 1/5 x on the right. Okay? Again, doesn't matter which side you bring them to. Now I'm going to multiply this by the reciprocal because it's a fraction in front, so I'm going to multiply by 5 over 1, which is the same as 5. So I end up getting 15 equals x. And you can write it as 15 equals x, you can write it as x equals 15, either one. Again, doesn't matter which side. Alrighty. Now, our key goal is to get the x's together. And I could subtract x, but then I have this fraction and all that stuff. So if you have a fraction where you have this, the x at the numerator, let's get rid of the fraction first. It's going to make our lives so much easier not dealing with fractions as much. So we're going to multiply both sides by 9 because that cancels this out. So that gives us 8 plus x equals 9x. Now it's so much easier for us to combine the terms because all I have to do, I'm going to actually just subtract x on this side and get 8 equals 8x. Divide by 8, x equals 1. Now, just to let you know, we have the 8 plus x equals 9x. I just want y'all to know what I was talking about. It doesn't matter which side. So let's just say I want to put the variables on the left. So I said I'm going to subtract 9x. Okay? So that gives me 8 minus 8x equals 0. If I subtract 8, that gives me negative 8x equals negative 8. Divide both sides by negative 8. And you get x equals 1. So you see how we still get the same answer? Doesn't matter which side. But for these ones, again, you want to break up that big fraction first. Alrighty, so we need to definitely distribute before we do anything else. So distributing, so I get 3 minus 3r plus 5r equals 2r minus 2. Once I have this, we can start moving stuff over, but I always like to combine like terms on the same side first, okay? It's not combining like terms if you're moving it over. So I'm going to combine those. So that gives me 3 plus 2r equals 2r minus 2. I'm going to subtract 2r first. Again, it doesn't matter which order. And then that gives us, that cancels out. Actually, that cancels out. So we end up getting 3 equals negative 2. Okay? I just want to let you know, if we get a false statement, that means the answer is no solution. Okay? No solution. So it says if you get to a point where both sides of the equation can't be equal, the equation is said to have no solution. Okay? Do not stop until you only have numbers left, okay? Some people like to think that if you're like, 2r equals 5r, you can always subtract the 5r and say negative 3r equals 0 and divide by negative 3. A lot of people say that that's no solution, but that is a solution. That does have a solution, okay? So don't get that confused. False statement, that's not the answer. No solution is the answer. Alright, so I'm going to distribute this. So 1/3 times 12x is kind of like 12x over 3, which simplifies to 4x. 1/3 times a negative 21, which gives us a negative 7, equals 4x minus 7. Alright, so I'm going to subtract 4x. And that gives me negative 7 equals negative 7. Well, that's actually a true statement, okay? We could even keep going and get 0 equals 0 if you want. But that's a true statement. If we get a true statement, that actually means all real numbers. So all real numbers, okay? So that's the answer. This is another way to write all real numbers. It's an R with that extra line in it. And I don't know why it's doing this to me. Again, yours should not be like that. Again, it's just having some issues. But it says when your solution is all real numbers, it is called an identity. So they're going to say that, this means, I don't know why it's messing up so much, this means that any number can go in for the variable and the equation will still be true. Okay, so I typically refer to that as, okay, I give up. It's done. I typically refer to it as all real numbers as the answer. So true statement means all real numbers. False statement is no solution. So there you go.